Welcome to Television. I'm your conductor, Mike Yawn, on our fast-track journey through Hazelcast's stream processing capabilities. We're once again hooking up stages using the Pipeline API. In this episode, we'll see how external services can be invoked directly from your Jet pipeline. These are some of the typical use cases where we might find ourselves using a service invocation from within a pipeline. Invoking a machine learning model to perform inference against streaming data is a great use of this capability. Business requirements such as fraud detection, retail recommendation engines, or predictive maintenance based on IoT data are some of the use cases we've seen. Also, when you need to interface with an external system, whether it's commercial software like SAP or Salesforce, or your own homegrown enterprise applications, a service invocation gives you that capability. And code reuse can be achieved by calling an existing service rather than re-implementing that logic directly in our pipeline. Now, if this approach proves to be a bottleneck, then we can always revisit whether to bring it into Hazelcast. This is a slide I've used in a few episodes before that summarizes the pipeline transformation APIs. Almost half of the stateless transforms are service related. And this is because when we're interfacing with something external, we want to have more flexibility in our interactions, such as allowing for both synchronous and asynchronous calls. We even have an invocation specifically for Python, in which the Jet pipeline manages the instantiation of one or more Python interpreter instances to make deployment of cross-language models easier to manage. And I want to call out in particular these three variations of the basic service invocation: map using service async, and map using service async batched. And we're going to look at how these give us power and flexibility in how we interact with our services. So here are the method signatures of the three invocation variations we mentioned. The first case is a synchronous invocation. We're going to call our service and block until it returns. Now this is what I'm using in the pipeline we'll show shortly. My service is local and it doesn't do anything that would block or take very long to complete. So it's safe to just call it directly in line. Our next alternative is to perform an asynchronous invocation. Our service method has to return a completable future of the return type that the following pipeline stage expects. Note that nowhere in the pipeline are we going to explicitly call get or is done or anything related to unwrapping that future. The pipeline manages that for us and simply invokes the following pipeline stage when the result of the asynchronous service invocation becomes ready. Our final alternative here is a batched invocation. A lot of time can be wasted in doing many round trips to the service, especially if the service is remote or if it has some per invocation overhead. So in this flavor, our service accepts a list of items and then returns a list of results. And once again, Jet is going to make this easy for us. Our pipeline doesn't have to collect these items into a list. We simply pass individual items into the map using service async batched stage, and the stage processor takes care of collecting the items into a list. How many items are a batch? It varies. Jet collects items until the previous batch of items is returned, and then sends the next batch over. So the batch sizes can vary depending on the arrival rate of new items and how long the service takes to process the previous batch. Now that we've covered service invocations, you might be wondering, how do we define the service itself so that our pipeline knows what to call? Here's where the service factory comes in. The service factory defines the service. Remember that Jet is all about parallelism. A lot of the performance that Jet delivers comes from how well it manages concurrency. The service invocation interface is one place where we're taking things out of Jet's direct control and handing off to something external. But Jet still wants to make sure that we're exploiting every opportunity to leverage processing resources. So it wants to know a few things about the service we're going to call. First, we tell it whether the service can be shared among processors. If our service is thread safe, it can be shared and will create just one instance of the service per member node. A service that isn't thread safe should not be shared, so we create an instance for each processor. Secondly, we'll let Jet know whether our service makes blocking calls. If the service is non-blocking, Jet considers it cooperative and will call the service directly from the processor thread. A non-cooperative service that might block should be offloaded. We'll offload these calls to a separate thread so the main processor thread can continue processing other items. Our code sample here shows how this might look for a call to a REST-based service. Our REST client is thread safe, so we can create a shared instance of the service, but the REST calls are blocking, so we mark it as non-cooperative. The Service Factories class gives us a quick way to create shared or non-shared services, as well as built-in services to access Hazelcast IMAP or replicated map data structures. There are also built-in services to access gRPC services, which are available via the gRPC services class. If your needs are more complex, you can use the various methods of the Service Factory class to build more complex services that have unique context objects to hold service-specific state. In each case, the create service function you provide will be serialized and sent to the member nodes for execution. The context parameter is a processor context object, and generally this is internal stuff you won't access, like the processor index and partition maps, but it does give you a way to access the Jet or Hazelcast instance, which is frequently quite useful. So remember that last time we introduced the Death Cross and Golden Cross patterns, aggregating 50 and 200 second windows to feed to the algorithm. So now we just need to define and then invoke the service. So we have a CrossDetectionService here that has two methods to support the pipeline, one to add a short-term moving average and one to add a long-term moving average. Both methods accept a ticker symbol and a price, and they're going to return a string. If there's no pattern detected, the string will be null, but if we do detect a pattern, then we return a description of the event suitable for display on the console. And our create pipeline method, we see here that we are calling, actually let me scroll up, we do a shared service here to actually create a copy of our service, and then we invoke it down in these methods where we were doing aggregations. We call map using service to the service we just defined, and in our 50-second average we call add short-term moving average, and our 200-second version we call add long-term moving average, and then whatever we get back we write to the console, the syncs.logger. So we can run this, and once it gets running we will start seeing some results back. Now if we don't get anything back from the result, we'll do a null, but here we see that we're getting a number of crosses back on different stocks. And we're probably getting more than we would see if we had real market data. The way I randomize the data to generate prices is in a normal distribution around the current price, which means the price tends to wobble around a lot rather than having a distinct up or downward trend. So we're getting a lot of crosses between the averages. But that's all I wanted to cover on the pipeline API. So let's jump into our recap. Jet pipelines can invoke external services to leverage code that exists outside of Jet, while still providing Jet's benefits of concurrency, high throughput, and low latency. We define our services using a service factory, where we flag them as shared or non-shared, as well as cooperative or non-cooperative. Our services can then be invoked by a map-using service pipeline stage. In addition to the simple invocation we used in our example, we can use map using service async to invoke longer running services, as well as map using service async batched to more efficiently move data between our pipeline and an external service. So thanks for hanging in on this multi-part series, and next time I promise we are going to move on to a completely different topic.